Hey everybody, we're going to talk about right triangle congruency focusing on hypotenuse leg today. So hypotenuse leg has to deal with right triangles. If you are proving two triangles are congruent by hypotenuse leg, you must have a right triangle. The hypotenuse between those two triangles have to be equal, and one leg has to be equal as well. Then we can say those two triangles are congruent. So we're going to do two proofs today on this, and then I'm going to work on an extra practice sheet. So hypotenuse leg proofs. So whenever we do the proofs again, you have to just remember, sorry, I'll start all over. Whatever we're given, you have to write that information. So triangle LMP and MNP are right triangles. So that means that is a right angle there. And this is a given statement. We're told that LM and MN are congruent. That's given. Now we don't have any information about angles. We don't have parallel lines. So we just have to see if there's anything else we could identify. These two lines here are the same because they're shared between those two triangles. So MP is equal to MP because of the reflexive property. Therefore, these triangles are congruent by hypotenuse leg. Okay. For this one, we have triangle WVX and triangle YZX are right triangles. Okay, that's given. So WVX and YZX. So those angles that are in the middle are those right triangles. WV is congruent to YZ. So WV is congruent to YZ. And X is the midpoint of WY. So that means WX is congruent to XY. Sorry, forgot to write all these. By definition of midpoint. So we have a hypotenuse and we have another leg. So therefore those triangles are congruent by hypotenuse leg. Okay? So mixed practice, proving triangles congruent. So what we're going to do is we're going to do all these proofs. So L is midpoint of KN and MP. That's given. So using this first part of that proof, L is the midpoint of KN. So we can say KL is congruent to LN by definition of midpoint. Then we're also told L is the midpoint of MP. So that means ML is congruent to LP by the definition of midpoint. Okay? So we have to look at this picture and we have to think what else we can identify. Well, I can see we have two angles here that would be equal. So angle KLM is congruent to angle NLP because these are vertical angles. Therefore, these triangles are congruent, and if we read it, side, angle, side. Okay. BD bisects angle ABC. What I'm going to do with this information is I'm going to identify the angles that are now equal. So angle ABD is congruent to angle CBD. That's a definition of angle bisector. Then we have angle BAD is congruent to angle BCD. So that means these angles are congruent. That was given. And BD is congruent to BD, the reflexive property. And the triangles are congruent by angle, angle, side. So you can't, if you do it this way, side, angle, angle, that's fine, but I mean, it's just not the traditional way we wrote all of our congruency. So if you read it as side, angle, angle, side, angle, angle, it's just easier to write it angle, angle, side, because that's what it's known as. You can't read it this way because we have a missing object here. Like you have to go directly to a next congruency, and you can't start in the middle because it does not lead you into anywhere. Okay, so you're always going to start to the outermost one, and you're going to go in the direction where there's another congruency that you can read. Okay, S is the midpoint of QU. That is given. So S is the midpoint of QU. So that means QS is congruent to SU by the definition of midpoint. All right. QR is congruent to ST. That was given. And RS is congruent to TU. That was given. How are the triangles congruent? Side, side, side. Got 3 more problems. So we're told that triangle FGH and triangle FJH are right triangles. That's given. And GH is congruent to JH. So GH is congruent to JH. That was given. And we can also say HF is congruent to HF because that's the reflexive. And that's it. I don't know why they have this line here. We don't need that line. So the triangles are congruent by hypotenuse leg. What they might have done is they might have taken this here and broke it into 2. Like they would have said, this is a right triangle and this, and then fill it in. But I'm sorry. Okay. All right. KL is parallel to NP. So KL is parallel to NP. And KL is congruent to PN. So what we do is we have parallel lines, so we can identify one of the 3 angles. We can identify that we have alternate interior angles. NPM is congruent to LKM. And we can also identify these vertical angles here. And if you read this angle, angle, side, you could have done this proof completely different, and instead of identifying vertical angles here, you could have identified another set of alternate interior, and it could have been sine, angle, side. But that's just another way. And last one, ty is congruent to xy. So ty is congruent to xy. And angle tvy is congruent to angle xwy. Sorry. Okay. For this, we're trying to prove that tvy and xwy, so like these triangles, are congruent. So we can have vertical angles here. I'm trying to think if tyv is congruent to angle xyw. And then we can say that the triangles are congruent by angle side again. And this was probably because they proved it a different way, but like I said, there's multiple ways that you can prove it, so we didn't need that other line because we identified vertical angles. Okay, so I hope this helps.